This video will show the answer to electric field practice sheet number 2, problem number 2. Problem number 2 states 2-point charges, Q1 equals negative 32 microcoulombs and Q2 equals plus 45 microcoulombs are separated by a distance of 12 centimeters. The electric field at point P is 0. How far is Q1 from P? And to do this, I'm just going to start by labeling some things. So this is Q1, which is a negative. This is Q2, which is a positive. This is point P. We're interested in finding this distance, D, and we know that this distance right here is 12 centimeters or 0.12 meters. So first, what I'd like to do is just label the electric field vectors at this point. Q1 is a negative, so it will have an electric field vector starting from P that goes towards it, and I'll label that E1. And Q2 is a positive, so the electric field at point P, due to charge 2, goes away. And the central idea, the key idea in this problem is that because the net electric field is 0, E1 needs to equal E2. And from that, we can begin to work towards our answer of finding D. Now, E1 is just K Q1 over D squared, D being the distance from charge 1 to point P. And E2 is K Q2 over, now this distance is a little bit tougher because it's the 12, but it's also D, so it's D, let's get rid of that, make a little negative there, D plus 0.12, and then we square that. And we have to solve for D. D is the only variable, but it's going to take some cross multiplying. So first thing I'm going to do is cross multiply both sides. I'll start that work up here on the right. It's going to be, actually I can divide both sides by K and cancel the K. That'll be an easy first step. Then I'm going to get Q1 after cross multiplying, D plus 0.12 squared equals Q2 D squared. The next step that I need to do in solving for D, if I have a D on one side and a D on the other, eventually I want to get all the D's to one side. But first I have to FOIL this out, so it's going to look like this. Q1 times D squared plus 0.24D plus 0.0144 equals Q2 D squared. Next, I'm going to distribute Q1 into all these terms. So I'm going to get Q1 D squared plus 0.24 Q1 D plus 0.0144 Q1, and that equals Q2 times D squared. After that step, I'm going to try to get this D squared to the other side of the equation and put it right next to my Q1. Get a little more room on the page. And then I'm going to get Q1 D squared minus Q2 D squared plus 0.24 Q1 D plus 0.014 Q1, and that equals 0. And hopefully you can start to see where we're headed with this. We have an equation where we have a D squared term, we have a D term, and then we have a constant term. So we're headed towards using the quadratic equation for this, but before I do that, I'm going to make things a little bit simpler. I'm going to factor out Q1 minus Q2, and that's D squared plus 0.24 Q1 D plus 0.0144 Q1, and that equals 0. And now we're really set up for using the quad form. This is my coefficient A, this is my coefficient B, this right here, coefficient A, and this is my C term. And Q1 and Q2 are just the charges listed above. No negatives. Don't put in negatives. Just leave the charges as absolute values. And I guess if you wanted to write it out, it would look like this. It would be, let me double check the charge here. It's 32 microcoulombs. So 32 times 10 to the negative 6 minus 45 times 10 to the negative 6 d squared. So that's my A coefficient, which is actually going to turn out to be a negative, plus 0.24 times 32 times 10 to the negative 6 plus 0.0144 times 32 times 10 to the negative 6. And that should equal 0. And you'll get two solutions, one being negative, but the positive one is the one that we're interested in, and that is 0.646 meters. And that is how you solve challenge problem number 2.